Thank you. Glad I have the opportunity today. And I know that you've probably watched Monday Night Football and seen the fastest 3 minutes in the NFL at halftime. And so I'm going to give you the fastest 30 minutes in agriculture, because there's a lot here, a lot to go through. But it takes a lot of every piece of every person in this room and puts it on the ground. And we practice what we preach. We take a lot of what exists and also new technologies and new ideas and new strategies and implement them. And we've called this program Producer-Driven Outcomes. And I started this a long time ago. And we opened the door and we said, okay, if you come to the farm, we share the data. There's nothing proprietary about it. That if you come here, we're all going to join in and hopefully build a success or a model that we can take across the road. That from the simplest level of integration of water management strategies all the way up to the sophisticated, innovative pieces, and apply those. So I wouldn't have been able to show you this 5 years ago. This is what our farm looks like today. And it's mind-boggling how we get up in the morning and take a look at what we're going to do next. It's not simply making sure that the tractor starts, that there's fuel in it, and that there's seed in the shed, and that the tillage is done. It isn't that simple anymore. We rely on information. And even more now, we create tons of it. And that's where the lag has been, is captivating and capturing and having that conversation about what do we do with this data, because we're building it. And finally, the rest of the agriculture has woke up, in particular the industry, and said, hey, we've got a helping hand, but they also recognize that there's some money to be made. Just recently, in fact, in the last 2 weeks, some young entrepreneurial startups out of Silicon Valley contacted us. And my son, Zach, just returned to the farm. He's a Doane and UNL kid. He just came back 2 years ago. And we sat down with him, and they said, what would work for you? And we showed them all the data that we're building, compiling, generating every day, and what do we do with this stuff? And currently, we're contracting it out. We spend a lot of time with John Deere. We're doing a lot of beta stuff with John Deere, not only in equipment, but also software and water management strategies. And this came to mind is, what do we do with all this? And who are the players? And I don't have time to go through all the players, but many of you are sitting in that room, from NRDs to the regulatory side, to also to the academic side. How do we face these challenges, but how do we get them to the ground? How do we take what you guys know and have validated, verified, and replicated and put it on the ground? Because we want it, but we got to have it in a form that we can use. I'm in the news often, not always the best picture taker. I think John Heason always tells me he has a voice for TV and a face for radio or something. But anyway, we spend a lot of time, and I'm an advocate. I'm an advocate for you. I'm an advocate for agriculture, but more importantly, I'm an advocate for Nebraska. And that's the bottom line for me every time. Is that it comes down to what is the right thing to do. And I'll tell you that over and over and over again. Bring your ideas, we'll host them, we'll do something with them, and we'll figure out what we can do with them. Precision agriculture. This will be pretty basic in terms of setting the foundation of how we arrived at a water management strategy, but it was a change in focus. And we're doing a lot of things at the landscape. We're not just doing water. We're doing seeding rates and variable rate fertility, of which I'll get to more here. And it's just maximizing production. That's not a word I really particularly care for. First thing they think is you're overusing or you're overcapitalizing on inputs and maybe not utilizing them in the best way. So we took the time. What's the base? Soil. My uncle told me 20 years ago, he says, I can put a crop on there, I can feed it, everything else, all I need the ground to do is hold the crop up. Oh, that's innovative. That's something I'm pretty interested in. And I farmed all the way from Valentine Sands with a 0.9, 0.8 water holding capacity per foot, all the way up to sandy loams that are probably in the 1.7 to 2.3 water holding capacity. So anyway, EC testing, we've done the whole farm. All we've done is validate what the USGS told us a long time ago. But what it has allowed us to do is really begin to get a handle on what our water holding capacity is across the whole farm. So you take those and look at the NRCS map, the old soil map, overlay the EC map. There are some differences. There's some distinct differences. And were we good enough to judge those? No. So we relied on a lot of people, whether it's DuPont, whether it's Monsanto, whether it's UNL, whether it's USGS, whoever it is. We try to bring as many of those components into that to help us. We also found that elevation maps played a huge difference in what we did in establishing not only fertility and seeding, but also water. So we put them in, we group them into 4. We've done that now for about 11 years. I've got fields that have 11 different soil types, and then throw in slope and elevation, and holy smokes, you talk about a challenge. But we can finally address that. We have the ability to capture the data and start to make layers of data that allow us to make management decisions. So we put them together. First thing we started doing was fertilizer. It was a no-brainer. But that caused problems. Is a lot of ours are stacked mixes so that you have phosphorus and nitrogen, potassium and manganese and zinc all in the same mix. So we variable rated those, and we were changing too many things. We couldn't identify what was the best piece of the puzzle, and we didn't have the equipment to carry it on. So we said, okay, that's still a component. Let's kind of back off that a little bit. Throw in elevation. We started doing seeding rate. We variable rate every acre. We haven't saved one seed yet on a pivot, and that's what I'll talk specifically about mostly is an irrigated circle of 130 acres. All we've done is redistribute it. We put it in places that have allowed us to start to, I guess a good word would be to get some uniformity to that whole field. That's a difficult challenge because of all the changes and all of the inputs that we actually drive on. So that water capacity allowed us to then, with all this baseline information, we were able to start saying, oh gosh, they came with this thing called variable rate irrigation. Okay, makes sense. How do we do that? It was a pretty simple piece of equipment. We actually developed our own to begin with that we just played with, and we just would do quarters, just a fourth of the circle to speed it up and slow it down and just change the applied rate of water on that particular piece of ground. We had tried to match it up to the water holding capacity on the map. And then since then, there are several now companies, startups, that are actually doing this and doing it well. And it's probably the least expensive on the ground way of applying water to your field. Somewhere in that $7 or $8 an acre. Costs another $2 or $3 to work with a consultant to develop these maps. But it was a great starter. And again, why wouldn't I do it? If I could start to not only measure the results, but start to change our application. That was a great idea. So then we really got nuts and decided that we would go to zone control. And I partnered up with Valmont, and this particular pivot is just right by my house. And our first attempt was, you take a look at that, there's over 5,300 segments that we tried to change our water application rates on this field. So you look at the EC map, you look at this zone control, and if you look at the orange spots there, those are farmed wetlands. I said, okay. NRCS was always in the conversations with us all the time. And I told Mary, I said, God, what an opportunity is those farmed wetlands. I can not water them, so no fertility, no insecticides, no fungicides. She says, whoa, 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 whoa. You got to water those. I go, why? Why do I have to water them? They're farmed. And if I choose not to do that, I only raise a crop about 2 out of 5 years, maybe 3 out of 4, depending on what the season's like. But why should I have to put water on them? It was another conversation starter in terms of what people's perception of what we were doing at the landscape. So, prescriptions. We've taken all this data, and we're trying to build this database and trying to turn it into a management style that allowed us to make good decisions. But we're changing so many things, it was hard to sort out what was actually making the difference. So incrementally, we would take it on different fields and then apply it to a larger piece and come up with these overlays and then start to see if we couldn't delineate those lines, see if we couldn't find them in the field with harvest. And I've used satellite imagery, I've used, you name it, as far as extrasensory pieces to give us some idea of these changes that we've made. Tillage, there's no doubt that tillage is a huge one. We've actually identified it's about a 4-inch savings for us. I should have said, I farm in the Upper Republican, the Middle Republican, and the Twin Platte NRD. So we are very regulated in the Middle and Upper Republican. And one of the things my son and I talked about, that this is a competitive advantage for us, is for us to be able to operate and look at these kind of strategies in the Republican basin as it becomes very restrictive. And a good example of that was 2 years ago when they hard capped our allocation and said you can't exceed this. And it happened to be in a year that we only got 1.73 inches of rain during the growing season. And then we could only pump 10.8. Well, corn takes 23 inches. So you got a little in the soil, you got a little rain, and you can pump so much, and it cost us about 50 bushel to the acre. Seeding, I talked about. Herbicide, swath control, there's site-specific stuff on this. It's awesome, some of the things that are coming. But again, these layers of data allow us to start capturing that, to identify, is that particular low yield, what's producing that? Is it weeds? Is it a low spot? What is it? And there's the report card. Harvest is no doubt a very important tool, but it's just a tool. A lot of people hang their hat on it. A lot of people have printed a lot of paper about harvest. But here's what I look for, and it took me a long time to get to this point, is trends. Is continue to do it and look at the trends and reach out to people that can help us to identify some of the changes, because this is the same field in 3 different years. And you guys won't be able to tell me what the differences are, but I can tell you right now, in 2011, on the north side of that pivot, I had 56% hail damage, right to that, almost to a line. But it isn't a line because that green that you see there that has a little better yield, it happens to be a different hybrid. And it just happens to be that it has a different structure, and it was had about the same defoliation according to the crop insurance agents, but it shrugged it off. We still don't know why, but it just happened to be the year. So these are the kinds of things that you can do the best thing you can above ground and start to put those models in place and those expectations, but you just don't always have the answers. So we get to the part that we're all here for, the water savings. I talked about strip tillage, off-season evaporation, holy smokes. We're not livestock people. We're doing less and less with grazing. I want as much residue. My dad would roll over in his grave, and my grandfather, if they saw what kind of trash we can farm through today. And that wasn't possible 10 years ago. It really wasn't. And now we can go through it. 250, 300, 320 bushel, you see that on the yield monitor. You may not have field average, but that is a lot of tonnage that's left out there. And so we want it left out there, and we want it chopped and spread so that it is totally covered. So that's why we pull the livestock off. We have a little bit of subsurface drip. We just fight the rodents. Bottom line, we just fight the rodents. I love it as an alternative, but we just have a heck of a time. We now employ speed control on 100% of our farm. We do it the KISS method. We break it down into quadrants, about 1/4 of the fields, speeding it up and slowing it down. We don't usually do over about 20%. My son does all of these now. It's still important to have a butt in the seat and to be able to understand what your field is. You can have all this data, you can have all this stuff, but it's still a physical observation that is also very helpful. Same with the zone control. It's not practical for us. It's too expensive, and it is a great idea. I think research-wise, it's really cool. In fact, we actually put a cover crop on this last fall. It was in dry beans. I grow as many as 11 different crops, but about 1/3 of the farm is in dryable beans, about 1/3 is in popcorn, then the other 1/3 is split between what I call the easy crops, corn and soybeans. Anybody can grow them. So by doing this, we went to wheat behind the dry beans. Again, consumption is a big deal. In the Republican Basin, under the allocation system, you're basically forced to less consumptive crops. So dry beans is less, corn is less. I'll show a slide here in a minute. But we also planted a cover crop on this. We just don't have enough season or enough, cover crops just don't work for us. But we tried it in this scenario. I have 130 bushel wheat stubble that stands nice, catch the snow, and I'm gonna go out and drill it with a cover crop. It didn't make a lot of sense to me. It cost me $56 an acre to put that cover crop in. We're hopeful to get, we did soil samples before and after. We're hopeful to get maybe 60, 70 pounds of N to help offset some of that cost. Very entry-level stuff. We'll get more to the how we measure and look at and evaluate those applications of water, but we started out simply with an ET gauge. And I have a lot of fun with the West Central, the guys there. When we first started with ET gauges, we started with one. So you log into the website and you have a username and password, put it in, great stuff, awesome. And then I had 16 of them, and one of the young grad students came out to the farm and he says, how come you're not using that? Well, we printed it out and we're just using it on a piece of paper. I said, start your watch. And I clicked into the website and I went to username and password. I put the first ET gauge in and I said, look at your watch, 51 seconds. Clicked into the next one. Well, you get the idea. 16 ET gauges later, I was there for nearly an hour. And I'm not gonna do that. I would love to do it because I believe in site-specific field ET. I believe in it, but just simple things like that would really help implementation of a great tool for a farmer to make decisions at the field level. And then we get to capacitance probes. I've had every manufacturer, I've had every database, I've had every piece of the puzzle that you can imagine for capacitance probe and soil moisture monitoring. We've done because we're metered, in 2 of the districts I'm in, we're metered. So one of the challenges I have, and the NRD guys always, they know where I stand. I'm not a meter guy, but I'm a monitoring guy. And what's the best tool? And how do we get it to the farmer so that it lands on his iPhone or it lands on his iPad or that he can make good decisions daily on, and it all ends up, and it's gonna be hard to see. I can't put it up on the deal here, but I'm not gonna get it. It's not gonna allow me. I was gonna show you today's data, but it's not gonna allow me to do it. So we did comparisons with ultrasonic using electrical meter rates. The AMR system, basically they're allowing us to control our pivot from our phone. And so we match up ultrasonic rates or mechanical meter rates and deliver that to your phone daily, just as a pilot program to give producers a tool to allow them to understand how much they're pumping and what they're applying and where they are either in their allocation or, most importantly, recognizing the resource. This was also a big eye-opener for us, is we over-irrigated early. The probes pointed that out to us. These are all models that we're all used to. Because our wells, we ratcheted them down, went to low gallonage, dropped our drops into the canopy. Then we got into the Julys and August when ET rates got up into the 45 and 50 hundreds. We couldn't keep up. But we stored enough in the soil. We kept our evaporation rates as low as we could and got us through to the end. So all of these models here, I'm just showing you now that this is the industry that's coming to us and saying, guys, we can help you. This is the ability for you to manage your water and do a lot better job and have yield and economic benefit. This is the actual website I was going to show you off my phone here, but this happens to be off Midwest Electric. All of my wells are on there. The green means their status is good. I can click on them, shut them off. I can restart them, but I participate in load control. Is our rates, I know there's several public power guys here, so I'm gonna have a little fun. But our rates, they do a great job. First with service and controlling our costs and getting us tools that help us manage that, because it helps us to keep our costs down, but it also allows us to manage the resources well too. So we participate in a 1 or 2 day voluntary load control. This is exciting. Valmont just took a 51% interest in AgSense. AgSense is a very simple box that is at the end tower of the pivot, and it adds value. There's several things. You can speed control with it. You can now get infield rain data. You can get real-time data off of your mechanical meters. Just a whole host of pieces that tie into the telemetry that get it in real time to help you with decisions on water. You can set in guns, you can set VRI, you can do a whole ton of things, but this is what it told us. This is an as-applied map last year in real-time data with my son. He developed this prescriptive map, and it's pretty self-explanatory. The highest application rate over the season was 13.9 all the way down to 9.59, and the average was 11.37. We couldn't capture that as of a couple years ago in real time. We get this daily now, is we can look at where we are. It'll predict what will apply. We can actually take a look at this and say, okay, we've got rain coming. This is the growth stage we're at. We can plug it into the model, and it'll actually tell us where we are. So then we match up the capacitance probes with infield ET, all of these tools, and they're helping us predict when to put the water on the crop. I don't want to spend any money. My water costs me between $6 and $7 an acre inch wherever I go. And if it's diesel, it's higher than that. But that's just an average cost. And pump performance and motors and providers, all there's a challenge to that. But I don't want to spend any more than that. So you add that up, 11.37. It cost me $70 an acre to apply that water. That's not depreciation. That's not a lot of other components in there. It's expensive to water. They give it a very definitive application, so you can really check. And down here at the bottom, you can see the total gallons pumped, the average PSI, and I can go into a whole deal now about application. But I work very closely with John Deere and their website development and some of the things that we expect. We get as-applied map in real time. When our tractor pulls out of the field, we have defined boundaries around every field. So by georeference, when it pulls out of that geofence, it sends the data to the cloud, and I have that day's work. Whether it's 5 pivots, 1 pivot, 2 pivot. We plant I have a 36-row planter, so we plant about 700 acres a day. We average about 70 acres an hour. So the data that's coming out of there, if we've made a mistake, we've made a hell of a mistake that day. So we need to know what's going on. It's not anymore the 8-row planter and I'm going to plant 95 acres. It still had the same economic impact in the end, but because we're driving this thing and all of those changes that we're doing, we're setting that base to where we have to be able to account for this. We have to have the tools that give it to us in real time. Am I close? Okay. Capacitance showed us this is where I irrigated. This is in real time to me. We irrigated it was too wet. This is another part of it that talks about profiles, some more about where it is. This is some of the changes in rainfall. I'm a guy, site-specific guy to the field level. You look at the variability there just from the NRDs, and those are rain gauges in each part of the farm that I have. The consumptive use I talked about, that look at the crops, it's easy to tell how we rotate, how we manage the allocations. We did it in dry land. We put probes in dry land. It's now helped us identify how we rotate and what crop we're going to plant in dry land. So our Water for the Future, we took all of this stuff, and the Nebraska Water Balance Alliance, I lead it. It's a grassroots group, but we took all that stuff and we put it into a project. And we have 11 producers from across the state, and we took all these things, put them in, asked them, and the participants are NRDs and many other people that have helped us, but deliver this across the state to start to talk about and look at and demonstrate some of these ideas and concepts. And that's it. Actually, I got 2 things. Hang on. I got 2 things. First, I got 2 questions for you. This is from a farmer's perspective. I want you to look at this picture. This is a center pivot that has a corner machine. You may or may not be familiar with that, but out on the end it turns to the left and bend around this farm, and isn't that cool? But here's the question that I'm asked the most. And this was the toughest question for me as a groundwater irrigator. I'm an NRD board, former NRD board member and stakeholder in the Platte Basin and all that stuff, but I have some responsibility to stream flow too. And when I first met Don Kraus with Central, we didn't talk nice to each other. And but we figured out, how do we have those conversations, and how do I speak best for myself and the people that I believe can make good decisions on the ground. But more importantly is, how do we get academia and everybody else, the regulatory side, to say, hey, guys, if you're capable of doing this, what can we do to help? And that's me. And I'm a guy that is, the reason we should do it, it's the right thing to do. Anyway, sorry to cut you off.
One quick question. I'm curious, have you started looking into the use of drones to help gather all this information?
Right now, I'm an early adopter, as you can tell. There isn't probably anything that I haven't tried or not applying, but the hard part with me with drones right now is I'm gonna have to hire it done. There's physically no way for me to go across 7,000 irrigated acres, and then what do I do with the data when it's done? And I've looked at a lot of different opportunities. We just think it's a little early for us. We have so much else going on. We think it will be a great tool for us later on in late season plant health. And because I grow so many other crops, kind of excited about the popcorn side and quality, and also dry beans, maybe on some disease because we do our own spraying, we get a really good look at the crop from the seed as well. And we're doing a lot more with satellite imagery. Anybody else? Yes, ma'am.
How did you measure consumptive use?
How do we measure it? Well, I'm actually working with two different companies that are providing the equipment and the telemetry that deliver that to us. Historically, we did it off of Dickens, Nebraska, which I believe was a database that went through several pieces to deliver it to us over the radio. And that's 47 miles from me out in the middle of a pasture. And that was probably one of the most telling things when I used that simple ET gauge at $150 a piece, that our field level ET, especially in different crops, was significantly different than what the weather station was telling us. Now we have infield. We've got some prototype stuff that we're using, that we're getting infield ET off the weather station and the soil moisture probe in the field. We just started that last year, and they're allowing us to plug in the actual hybrid. So you have the GDUs, and it predicts the growth stage, and then helps us also predictively to apply water.
So it's a combination of what's typical for that, and then plus what you've actually measured in the field.
Yes.
Okay.
Yes.
All right. Well, thanks, Roric,
You
for
bet.
that
Absolutely.